All right, boys and girls, welcome back to the drive-thru for a special live studio audience performance. Shout out to Peyton, Caitlin, Anne Marie, and Alex in the house. Okay, we're going to do this pretty quick, so don't be alarmed by how fast we go over this, because it is a video. I just recommend you guys follow along, do a little Q&A so you guys can answer my questions. And then I would go back and rewatch this video. I think we can do this in 15 minutes or less. And then you can skip through the parts you know, and you can go over the stuff that you need more than once. Okay? Thank you so much for coming. Add Abby to the list. The studio audience has grown, and we're off. Okay? So these are the words you need to know on the test. These are literally the most important words from the directions. So I am going to read to you, but you don't need me to. Simplify the exponent. Simplify the radical. Is this arithmetic or geometric? Explicit and recursive formulas. Slope. Intercepts. Two of them. Slope-intercept form, point-slope form, and then graphs. Okay, the graphs you would certainly be encouraged to use your graphing calculators. And we're off. Okay? X to the 5th times x squared. Well, if you ever get confused, you can just write this out. 1, 2, 3, 4, 5, 6, 7. Hopefully you know the rule that when you multiply like bases, you add the exponents. So if you multiply those, what is 3 to the 4th times 3 squared? Well, it's just the top. It's 3 to the what? 3 to the 6th over 3 to the 7th. Okay? So what happens when you divide like terms? What do you do to the exponents? You subtract. So that is 3 to the negative first, but that's not how we normally write things in math. How would we write that? 1 over 3. And if you want to have a 3 to the first, that's totally fine. What's up, Ethan? Hey. Okay? Does that help? All right, square root of 32. There are two different ways you can do this. Okay, my way uses the perfect squares. So in my head, I have 4, 9, 16, 25, 36. I know those numbers. Okay, so I look at 32 and I'm like, ooh, 4 goes into that. 16 also goes into that. See, the math numbers really help. So I would call this the square root of 16 times what? Times 2. Very good, Peyton. Is that what you said? And what is the square root of 16? It's 4. So you can bring that out, and you get 4 radical 2. Now, another way that I taught it was just to get it to its prime factorization and look for pairs. So 32. Most people think of it as 8 times 4, right? But 8 is 4 times 2, okay? Right? And then once you see a pair of 4s, you can pull those out. Because the square root of 4 times 4 is just 4. That's literally what the square root means. It's the opposite of multiplying something by itself. So far, so good? Okay, this is an old school throwback problem from chapter 1. Are these geometric or arithmetic? Notice I chose big ones to try to throw you off. It kind of looks geometric because it's getting big quick. But how did we get from 12 to 18? We added 6. Let's test it. 18 plus 6. 24 plus 6. What is it? Arithmetic. Okay? The formula y equals negative 3x plus 6. You might want to jot this down on your test. Which form is it in? The one on the left or the one on the right? The one on the left. It's the one we like. It's slope-intercept. Which of these letters here represents slope? What's the other letter that matters? Yep, and what is that? Alright, so that's just a little bit of review. Okay? So, what is the slope in this question? -3. Okay? What's the y-intercept? What will we do to write this in function notation? Come on, you got this. Don't let the notation intimidate you. Oh no, no, you're thinking recursive. We're just taking this from this. Yeah, but not -3. You're the one that picked n, Anne-Marie. So since it's a function of n, plus 6. Now, what if somebody said f of x? Then it would be -3x plus 6. So I just want it. You chose f of n, which was totally fine. Well, then that means our variable needs to be n. If you would have chosen f of x, you could have kept it the same. All good, okay? All right, now the recursive. We need two things for the recursive. Who can give me one of the easy things? Abs? Okay, so what is that? F of what? The y-intercept is important for explicit. What do we need for the recursive? We need two things. Alex? Yeah, we need, well, before we go into f of n, Anne-Marie, we need a starting point. So let's pick an easy one. Anne-Marie, f of what? She picked 1. I want everyone that's listening out there on TV, because there's thousands of people watching right now, okay, to know that she could have picked any number. But now that she's picked 1, how do we find out what f of 1 is? We plug it in. What's -3 times 1? -3. And what's -3 plus 6? +3. Very good. So that means if we put in a 1, we get out a 3. Now, Abby, go back to your f of n thought. So we're talking recursive. So to find f of n, from a recursive standpoint, what do we do, Abs? We take the previous number, excellent, which is called f of n minus 1, and what do we do to it? Do we add, well, we add the slope, is that what you said? So I could do plus -3, but what's a better way to write that? Does that make sense? Okay? Everybody good? Alright. Do all the following based on the graph. Write the explicit formula in point-slope form. Okay, so what do we need to know to write something in point-slope form? Anne-Marie? Okay, you need the formula. Good. Do you know the formula? Okay. I'll take either one of them. Plus y1. I will tell you that nationwide, that one is barely ever used. You're more likely to see the other one on the test, which is what, Alex? Very good, Alex. Okay, but either one of them will work fine on the test. For some reason, this book seems to prefer the first one. Doesn't matter. What we're going to get good at is seeing things in different languages and being okay with it. Okay? All right, so what does all this mean? Well, that means we need a point, and we need the slope. Okay, well, this next part is where people get thrown for the biggest loop. They're like, I don't know which point I'm supposed to use. How many points are on the line? infinite. So you have infinitely many options here. So just pick one. Okay? Pick one, Caitlin. Say it again. Well, you gotta give me an ordered pair. An ordered pair. So give me a point that's on the line. Yeah, it is hard to see, isn't it? Let's see. This is 6, and that's 8. Let's see. It doesn't really have another. So we better use this one, right? So what is that point? Not -7, 0. 0, -7. We go right 0 to go down 7. Sorry. So 0, -7 is a point on our graph. Okay? How do we find out the slope? Plug what into what? Let's look at this point right here. I think that's another point that's definitely on a whole number. God bless this machine. I'd like to thank whoever decided to get me this ViewSonic. All right, here we go. Okay? What's that point? Get up and walk here. Come on, walk up here.
1, -4.
Yes, it is. This is 1, -4. And this is 0, -7. So how do we find the slope between those 2 points? Yes, yes. All right, so we'll do -7 minus -4, so that turns into a plus, divided by 0 minus 1. Okay? So on the top, you get a -3. On the bottom, you get a -1. What's -3 divided by -1? 3. Okay? Now, at this point, you should look at your graph. In algebra, you have a chance to check your answers just by checking to see if they make sense. Does that graph look like it's a positive slope? It does to me. This is how I want my money to work. I want it to go up. As time goes by, I want my money to increase. Okay? So that is a positive slope, and it looks like it's a pretty steep slope, and 3 is pretty steep, so I'm good with it. So, point slope form. Let's come back to that. Let's just get our slope intercept done. What's our intercept? -7. So, Alex, what's our equation in in slope intercept form? Excellent. Y equals mx plus b. So now give it to me with the numbers in. What's our slope? It's written over there. That's okay. That's okay. The board's small. The slope is 3. And the y-intercept, where does it hit the y-axis? There you go. Okay? So far, this looks like this is one of the harder questions. How can we write it in point slope form? So y minus 0. Sorry, I did that wrong. Y, what's our y value? Y minus a -7, so that turns into a positive, equals, come on. So what's our slope? 3 times, not 0, x minus 0. Okay? Got it? So that might be something you guys got to rewatch. No problem. That's why we make a video out of it. Okay? The last question. Graph these things. Okay, all I want to do is just show you how to put these into your graphing calculator. So pause the video for a second. Okay, so really the more useful thing is your table. So if I go y equals 2x minus 7. Okay? First I'll graph it. Well, that one I can see pretty nice on my graph. It's a line. I expected it to be. The y-intercept is negative. I expected it to be. The slope is positive. I expected it to be. Now all I need is some points so I can put them on my graph and connect them. Well, for that, you want to access the table. So I hit second graph, and there's my table. Okay? So I would just, again, you're going to have graph paper, so don't freak out about this. 0, negative 7. What's 1? Does it say negative 5? 1 is negative 5. Whoops. 2 is negative 3. And so there's our line. Okay, on your test, you'll be more accurate than that. All right, now, so let's go back to my equation. Let's clear that one. Let's type in 2 times 3. This is to the power of x. Okay, we're almost done with this. What do you expect this graph to look like? Is it going to be straight or curved? It's going to be curved, which is exponential. Where is it going to begin? It's going to begin at 2. And then it's going to go up by 3 for every unit of 1 that we go over. We're going to multiply by 3. So it's going to go up super fast. Let's graph it. Okay, that's exactly what we predicted. Notice it does indeed start at 2 and go up fast. So for this one, I'll just give a rough stretch. 0 will be 1. What the heck? Oh no, 0 will be 2. What's 2 times 3? So 1 will be 6, and it gets big fast, and that's going to be our graph. And are you guys ready for this test? And can I get a boom? Boom! Thank you, Abby. Thank you, Abby. Everyone else that doesn't want to play. Boom!